Good morning. Good morning, everyone. Can everybody hear me okay? So thank you all for attending. I don't know if you've noticed at this particular forum, we have a lot of sessions about analytics. So maybe just a show of hands, how many of you have solutions for analytics or are implementing analytics in your organizations? I'm just curious. Or is this all new? Good. Okay. So I'm going to take a certain slice of the analytics market because, as you know, those of you that have come to forums before, we're about process, hybrid, and discrete. I'm going to give you a process-centric view of how we see the analytics market. But to start with things, I want to take you back to 1968. How many of you remember 2001: Space Odyssey, Stanley Kubrick? I think most of us are all engineers. We'd be very much into science fiction here. But I want to contrast what Stanley Kubrick wrote about aboard a spacecraft that was orbiting Jupiter with how modern process operations and maintenance people are working today. So on the left-hand side, you've got this astronaut, Dave Bowman. He was the guy, you remember Hal says, "Dave, what are you doing?" Right? So he's the subject matter expert, and he's going to be the star of this little introduction to process analytics. And then there's this thing on the other side called HAL 9000. And really, well, what's HAL today? Well, HAL is the artificial analytics, right? So HAL is the predictive and the prescriptive analytics, right? So what Stanley Kubrick and Turner Broadcasting wrote about and produced back in 1968, we're finally realizing this today. So before I get started talking about why this is important and how it relates here, I have a 1-minute video that I want to play from this movie.
I've just picked up a fault in the AE35 unit. It's going to go 100% failure within 72 hours.
It's still within operational limits right now?
Yes, and it will stay that way until it fails.
Would you say we have a reliable 72 hours to failure?
Yes, that's a completely reliable figure.
Well, then I suppose we'll have to bring it in, but first I'd like to go over this with Frank and get on to mission control. Let me have the hard copy on it, please.
X-ray Delta 1, this is Mission Control. Roger, you're 2013. Sorry you fellows are having a bit of trouble. We are reviewing telemetric information in our mission simulator and will advise. Roger, your plan to go EVA and replace Alpha Echo, a 3-5 unit, prior to failure.
Okay, so what just happened there? Did anybody notice? So Dave Bowman, the process operator, the engineer, there was no flood of alarms. There was not the reaction of dealing with a major process event or a catastrophe. There was a well thought out process that helped make sure that the spaceship could actually continue to communicate. So those of you that remember the movie, the AE35 unit was actually the main communications back to mission control. Pretty critical for a spacecraft. But if you think about what happened, so just prior to that video clip, Dave Bowman was in conversation with Hal, and there was an interruption because Hal identified a failure, 100% failure within 72 hours. So this wasn't a threshold type monitoring application. This is where Hal is looking at multiple pieces of data, contextualizing this, looking at history, and identifying a failure. So the first question is that the engineer or the subject matter expert says, is it still within operational limits? So the operator is trying to determine is this asset within my operating envelope, right? So the reality is that you get this dialogue between man and computer. So 1968, this is what they predicted, right? So fast forward today, this conversation is taking place, and all this information is available. But what's really interesting about the dialogue is they're not dealing with certainties, they're dealing with probabilities. So the astronaut says, do we have a reliable 72 hours? So basically this exchange is identifying false positives, whether this is reliable, whether or not they actually have to invoke another process. But what they did is the process that they started was something called the performance improvement process. where they decided to take a bunch of readings. They didn't immediately engage maintenance to remove the device. They consulted their external expertise. So this is the big strategic lever that we see for analytics in process industries. It's this process, and it's using technologies to help make sure equipment is reliable. So we have developed a maturity curve over studying this market for several years. So this is what we call maintenance and operations maturity. So the big differentiation here is a lot of organizations have started at the bottom where most of the effort on the engineer or the maintenance person has been reactive or preventative. We saw the emergence of condition-based technologies about a decade ago. And now we're using machine learning algorithms and other sophisticated tools to absorb massive amounts of big data from multiple different sources to do predictions. Some systems are actually quite clever where they can actually identify patterns, do explicit diagnosis, and actually point to precise outcomes and repair techniques or efforts to avoid catastrophes. So the reality is that organizations today are probably 3 to 5% of all maintenance is predictive. Probably a little bit lower because some companies consider condition-based monitoring to be predictive. But this is how analytics is impacting operations. So what does this mean from an asset point of view? So when I think of process assets, I'm thinking of things that spin. I'm thinking things that distill. Exchangers, motors, all the things that you have in your process today. But what the goal is ultimately for organizations is to improve uptime, reduce costs. Those are the typical things that companies want to do. But really what we want to do is we want to continue to shift this curve towards the left. So if you look at the vertical axis is asset performance, and the time along the bottom, the goal here is to not just identify bearing failure or some issue with the asset. In the process industries, the real key here is to identify the process triggers or the things in the process that are causing the asset to fail. So there's been a lot of studies about predictive maintenance. Most of these are asset-centric. So most of the studies point to the same thing, that 82% of all the failures are all random. And there's several studies from the US Navy, aerospace, they're all completing these studies. But what we would say is that in the process industries, the assets are failing because of the way that they're operated. So some of the mean time to failure actually doesn't apply. So when you get guidelines for mean time to failure from your manufacturer, they're done under pristine operating conditions. So this is where we look to analytics as a way to decrease that uncertainty and lower the risk in that 80%. So we can't talk about analytics without some structure. So because a lot of things are analytics today. So what we found is that we needed a taxonomy to describe this. So on the left-hand side, we have what we call performance analytics, which is basically a lot of the tools that we've had for many years. And this is the what has happened, this is the dashboards, this is the simple drill down tools that you've had, the multivariate analysis tools and the more basic tools, but they're good for reactive decisions in real time. Usually there's some damage done, but you're still able to avert a crisis. But as you start moving to the right-hand side for different work processes, this is where you're looking at what's likely to happen using the predictive and prescriptive type techniques. This is where big data, machine learning comes into play. This is where capturing IP from workers, putting it into the system comes into play. But usually what we can say about this is usually it's not just crisis averted, this is usually avoiding the damage. So going back to that performance failure curve, you're shifting the curve to the left to change the operation before the asset fails. So, and this is a common point of discussion about analytics. So I want to present something here. Often companies will say, I can't do analytics because it's too complicated and I need to hire a data scientist. So this is how I would see a data scientist. A lot of the skills are similar to what engineers are today in facilities, but there's some differences. Is the tools that they use and the way they deal with data is very different than the way process engineers have dealt with data or operators. So you can't find many process engineers or operators in facilities today that are really good at using concepts like MapReduce or experience with databases as a service or parallel query processing. Those are just not common. So the dynamic here is that we see as the predictive and prescriptive analytics get more complex, this data scientist needs to be in the box and make it simple for engineers to use. And there's many solutions today that are providing this capability. So in terms of opportunities that we see in the process industries, this is not just about common things that spin or rotating equipment or motors. We see this really across many different aspects of the process industries, everything from variability to preventing column flooding or foaming or issues with exchangers plugging off. These are all typical assets that you might see with a process. It could be quality, and of course asset health is the common one. But the other thing is about keeping the facility safer by avoiding incidents.